So this is the main theorem of the Galois theory. So we have proved that given the Galois extension E over F, there is a Galois group associated with it, G of E over F, and given the Galois group G of E over F, there is an associated Galois extension with it. So consider the set of all the subgroups of this G and set of all the subfields of E which contains F, then there is a one-to-one bijective correspondence between them. That is what we want to prove. So we will define a map phi from S of E over F to S of G. So we define that, suppose L is a fixed field, so L will be what? So this is E and this is F. So there L will be intermediate field between them which contains F. Okay, so and it will be mapped to what? It will be mapped to G of E over L. So this is the subgroup of G. Okay, and psi with the reverse map, inverse of this, S of G to S of E over F, and suppose H is a subgroup of G, then it will be mapped to what? It will be mapped to this set E raised to H. This will contain all the elements of E which are fixed under these automorphisms which are from H. So H is a subgroup of G, and this H will be mapped to the fixed field which contains all the elements of E which are fixed under all the automorphism of H. Okay, so now we will consider, to show the bijection, consider phi of psi of H. So psi of H will be what? Psi of H will be phi of E raised to H, and this will be exactly all the elements which are fixed under the subgroup H of the E. So it will be exactly what? The subfield L, and we know that phi of L is G of E over L, and this is exactly what H is. Okay, and it is subgroup of G. So we got that this map phi of psi of H is identity map, and next we will say now psi of phi of, say suppose this is fixed field L, then what will be the phi of L? Phi of L will be G of E over L, and what will be the phi of G of E over L? It will be E raised to this set, E raised to G of, and this will be exactly what? The subfield L. Okay, so we got this map, this both composition as identity. So that proves that there is a bijection between these two.